And we're recording now. Uh, Welcome, everybody. My name is Joaquin Milata, and I am the host of the AI Digest. With me today is Matthias Sesboue. I have the worst time pronouncing his name because I'm not a French person. How do I pronounce your name, Matthias?
You're actually getting better each time.
Every time. How many times have I
I,
tried? 8 times
I
now?
told you French people they cut the sentence, so it says boy and no longer stuff. Says boy, very sharp.
Sesboue.
Yeah, that's good. That's pretty
Okay.
good.
I'll work on that. So Matthias is a computer scientist, and he's near the end of his PhD career. He's soon to become a Doctor Matthias Sesboue, and he has some information to share with us about his academic journey, learning about neuro-symbolic artificial intelligence or whatever the most recent marketing term for that is. But he has a huge interest in what is pragmatic, what works, and how to implement the technical details of artificial intelligence with symbolic reasoning, symbolic technologies. Um, does that justify who you are, or is there anything else you'd like to add to that?
I guess we can tell a long story about who anybody is. So, but that's a pretty good one about the scientific part, let's say. So yeah, I'm finishing my PhD. You're right. It's in computer science. Maybe you should mention that I'm working with a company at the same time. It's not
Ah, yes.
only an academic work. So hence the applied part. I'm
Mhm.
looking for stuff that actually works, or maybe they don't all work, but I'm considering the technical aspects and is there a chance that it works in the short term? So yeah.
I think two things I forgot to add is that you speak three languages and you're a black belt in judo. But
Okay.
um, so today we're going to discuss your academic journey, and I leave the floor is yours. What do you want to share with the young Matthias 5 years ago? If you were to start
Okay.
from scratch, what would you do different?
So okay, maybe I can start with summarizing the my resume, let's say, or my the path I took. So after high school, I went to the school, engineering school, which is the equivalent of the university in the US, I guess. And so very generic. I took the 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 computer
Science.
science department,
Mhm.
and but that's like the technical part, like just the learning path. Along the way, I did some internships, and actually the first one was like in India, deep down in a little company in India, and that's the first time I heard about the term semantic, and in particular the aspect of semantics that is the semantic web-based notion, let's say. So I heard about OWL, RDF, all those technologies tied to reasoning, the with the keyword semantic, and really at the time it was only the keyword. Then I come back and I had to France and I had another internship and I actually moved to the US for the first time, Colorado. I went to Semantic Arts for an internship as well. Really started to dive into the ontologies, our reasoning, all the stuff. And I lost myself. Oh yeah, then I went to Canada for a semester, then moved to Texas for another internship, the last one, and then started the PhD, really focusing on how to use a knowledge graph, um, which is like a combination of the ontology and the data, let's say, to enhance search engine. And in my case, the search engine is the Trustparts search engine. Trustparts is my company, and they have a website on which you can download 3D models of components, industrial components like screws and bolts and nuts, as you know. So, so yeah, I'm trying to enhance this search engine using a knowledge graph. That's the broad topic of my PhD.
So I would just like to add that this is the second time we're having this interview, and the
Hmm.
first time we spoke, I'm just going to reference that we made mention as to um, the nebulous idea of artificial intelligence, and do you want to just talk a little bit about that? We're going to be very narrowly defined uh, with artificial intelligence relative to knowledge graphs, knowledge representation, right?
Hmm.
Representing concepts via ontologies. Do you want to talk a little bit more about how you would define it in that context?
So I guess there are probably a lot of like philosophical reflection about what is artificial intelligence. But as you said, I'm more a practical person, so I'm going to try to tie how it looks like. Um, so behind artificial intelligence, we put a lot of methodologies, a lot of technologies. The most well-known one right now are the large language models, and with this ChatGPT. I'm not working there. I'm working on a slightly different place where they try to explicitly represent the knowledge that is in the head and use that to reason. So it's literally trying to model what is in our brain to have a machine use it. That's the main idea. So I don't know what is artificial intelligence, but I would say that this knowledge graph space, I say knowledge graph because the way we currently, one of the way we can represent the knowledge we have in human's head is using a graph structure, and hence the fancy name knowledge graph. And yep. So,
Since I mean, since the prehistoric times, I don't know if you
mhm.
saw the cartoon show when you were a kid or if they show it in France. The Flintstones. Do you know the Flintstones?
No, I have no idea. I haven't looked a lot of TV shows, so.
Okay, well, the Flintstones is a TV show about a family living in the prehistoric times. They wear
Oh.
dresses and they drive with their feet in cars. But since that time, and for a very long time in our society, we have this concept of tribal knowledge,
Hmm.
right? Where you and I were part of a tribe, and we live in it, we grow in it, we have experiences, shared experiences, we have a language, we have a shared understanding of that language, and we can build on that with people. But say
Hmm.
everybody dies and you're the only person left, and then you have to go join another tribe, or you leave and our tribe is intact, we lose the knowledge that you carry with the loss of a person. So it's important to have knowledge be documented and represented in a way that we can share the meaning apart from just the group that is there, right? It is the
Hmm.
next evolution in how we deal with knowledge, because a book is only a reservoir of knowledge, but it needs to be interpreted. This is something that kind of just takes the value of the knowledge, the meaning of the knowledge, and stores it and keeps adding to it, right? A knowledge
Hmm.
graph.
Um, yeah, that I know actually this cartoon. Sorry, it's just the English name I didn't know.
What do you
For
call him?
your own, yeah, Pierre à feu, la famille Pierre à feu, family, and
Yeah, yeah.
Pierre à feu is Pierre is stone, feu is
Oh,
fire. Anyway, so I get the idea. I haven't watched it, but I know what you mean. Anyway, and I agree with you. And the thing that is, you make me think about this. I think right now, you said, imagine everyone dies and you're alone in your community and you gotta move into another community. I think that's kind of what happened every day because at least around the term knowledge graph, it's it's not a new term. So scientifically, the term is very old. I think it's from the 80s, the first time we could see. But I mean, it's more popular since at least 2012, and now it's even more popular. But it's used in many different communities. and those communities, they speak different languages.
Hmm.
They, by language, I mean, I'm not speaking about French, English, whatever. I'm speaking about the technical word you use to express your thing into your community.
Hmm.
And and that's why I think um, so it all of those communities, they are using the term knowledge graph, and they have to talk to each other. So one example is the um, what I would call, so I got to invent new terms so that it makes sense that your community behind knowledge graph, I'm going to speak about ontologies and someone is going to speak about knowledge graph. Um, and no, that's not a good example.
No, but I hear what you're saying. We have the same word, but we have different understandings for that word, and
Hmm.
we use different words to represent the same meaning or the same idea. So I could be talking about ontologies, and you could be talking about knowledge graphs, and we mean the same thing. But because we're using different words, it fragments the understanding from an outside perspective, right? Is
Hmm.
that what you're gearing towards?
Yeah, but it's actually a good thing as well because it takes a bit more time, but once you understand, you talk to someone, you use the term knowledge graph, this person is using the term knowledge graph, and at some point you say, oh, but we are not actually exactly speaking about the same thing. We picture something different, but then it drives your imagination as well, because that's maybe a point of view that you never heard about. Um, you didn't know you could imagine this behind. So it's just driving a new idea in your head that maybe going to grow and end up into something. But that's how it is in life. You just learn stuff. I'm deriving there. So let's go back to your point.
I mean,
There is communities talking to each other. So
ontologies is something as old as Socrates, as old as the Greek philosophers, and even before that,
mhm.
right? How do we reason with
So
knowledge?
yeah, that's actually you. So the thing that you're mentioning here is that the ontology thing, it comes from philosophy. It's very old, and but at some point they start to bring this ontology idea into computer science. And in the papers I'm reading, there is one from, I think it's 1998, from Guararino, I think the name is. And at this time, in the paper, he already noted that there is a confusion between what is an ontology, right at this time. And he mentioned the two communities were actually the philosophical and the computer science. So you had a notion of ontology in philosophy and a notion of ontology in computer science. And I think today it's the same with knowledge graph, different ways because different point of view. So that's why when I speak to people, I try to make clear, or at least for myself, try to detect what they are thinking about behind the knowledge graph. What do they picture? So,
When you filled out the form that is kind of used to structure and develop this
mhm.
conversation, under the fun fact, you said that knowledge graphs are supposed to bring meaning and order to the chaos of language, but the practice, the scientific study of knowledge graphs is so obfuscated and scattered. So it's kind of ironic.
Yeah. Um, well, maybe that's my point of view from someone that is learning. So maybe if you ask more older experts, they're gonna tell you they know, and that's what it is. But as for everything, there is a different point of views. So when I said that is tied to knowledge graph or ontology, there is always the keyword semantic that comes in at some point, reasoning, semantic, and stuff. A semantic is about meaning. So, but the term semantic has different meaning for different people. I find it like kind of a loop. So there is actually one work that I know where that I've read. It's a book that is called Knowledge Graph. Many different researcher try to precisely define what is a knowledge graph, like in a mathematical term, giving example, and they had to make a distinction between the knowledge per se and the data. So within a knowledge graph, they actually say you have two kind of graph, two different graph, if I make it simple. One about the domain knowledge. So that's what they call the domain graph, and what one that is actually your data, that is the data graph. And the one that contains the semantic and actually describe the semantic is the domain graph.
I think that's the cleanest, and I think that's the most useful visual description I've received to this date on knowledge graphs from my own ignorance.
Mm,
I like that. You have knowledge and
thanks.
you have data, and integrating it makes a knowledge graph because you're making sense of
Mhm.
data, right? Like that's the whole point.
But that's yeah. You without the data, the knowledge is not that useful. That's but there is also often the knowledge pyramid that comes in. The thing, different layer at the bottom, you have the data, then you have information, then you have knowledge. And depending on, there is different words for the top level, but the one that I use is wisdom. Yeah.
Mhm.
But you can use other ones. I've seen other version anyway. And the wisdom is like the part that say, okay, knowledge is fine, but knowledge is, alone is useless. It becomes useful when you reach wisdom, which means you're actually using the knowledge to do something. And I guess you gotta use the knowledge with the data. It's so yeah. That's an example. In this work I'm mentioning, they say something very important also when we speak about knowledge graph. I told you there is the domain graph, the data graph, but they also say you should make the distinction between the graph structure. So that's a choice. You choose to represent your knowledge using a graph. You could represent that in many different ways, but since you have knowledge graph, they're going to be a graph. So you choose to represent knowledge using a graph. Then you have the schema, which is like the schema can take many different form, but there is the topology of your graph, but also the
Like the architectural blueprint of a house. That's what
kind
you
of,
mean.
yeah, yeah. But you gotta make the distinction between those two things, and there is a third one. Oh shoot, I forgot about the third one. I said schema. As I said oh yeah, there is the knowledge, the schema, and the structure, the data structure you're using. You get the and though I find this way of thinking pretty interesting because when you're speaking with someone about a knowledge graph, someone that actually implement knowledge graph, those three components, if you clarify what they are for the other person, I think it gives you a pretty good idea of what the person picture behind knowledge graph. Okay. Maybe I'm going too much into technical
No, no,
side
no.
right
Please,
now.
like the more you describe, the more detail you put behind this idea, and the more we try to ground it in
Hmm.
visual concepts. I would imagine the easier it is for us to transmit this idea to potential audiences,
Hmm.
or the audience. Okay, so we've talked about what you've studied. We've reasoned with these ideas a little bit now.
Hmm.
Tell me, who cares? Why is this important? Right? Why do we need to know about knowledge graphs? Why are you studying it? Why are you building this system for trace parts?
So the system for trust parts is just the use case. What I'm interested in is the tool, and the tool is the knowledge graph. But to really understand the tool, you got to apply it on a use case, and it happens to be a search engine. Uh, though a search engine is very useful. You have more and more information. If you're able to find information faster, it's going to be always. I mean, you can start from there much quicker. So that's good. But the knowledge graph is really the tool, and I think it's one tool among many other ones, and it's definitely a very powerful one because the when you structure your knowledge into a computer processable format, that's where the computer is going to be, it's a machine, it's going to be way faster than you. So you can use it to derive many things. And I don't know, maybe there is different ways to, for sure there is different approaches, but the knowledge graph one is the coolest one nowadays. So I'm like any human, I'm following the wave, let's say. And and I think it's yeah, a very powerful tool. And it's actually, I mean, studied a lot since many years, and it's, I think it's one of the thing that has been done, one of the tool that has been identified as a good candidate to explain the knowledge that is implicitly encoded into those large language models. I think that's one of the reason why there is the a new hype on this knowledge graph thing. Imagine how cool it would be if you could explain in a human understandable way what is encoded exactly into a large language model.
We've had this conversation when you visited in New York City. I think two
Mm-hmm.
Saturdays ago, we were talking about the difference between inductive and
And
deductive
deductive. Yeah.
reasoning, right?
Mm-hmm.
And we also try to distinguish the difference between statistical and symbolic artificial intelligence and how that's relevant to inductive and deductive. Can you give us a little bit more on that?
Mm-hmm.
You tell me in 1 year, and I'm painfully like it just comes out the other. It's such a dense idea. I don't.
We, yeah, we had so much fun these days. The when I was in New York with you, that was, so I can understand that you were distracted. So many things happened. So um, I went and I forgot a lot of what I said. I don't want to go too deep down, but I try to into the technical details. But I try to also, one of the things that wanted with this interview is to point out what I would have loved to know
Mhm.
when I studied my PhD, and everything I said so far is stuff that I would love, that I'm understanding now, or I believe I've got an understanding. Sorry, and I would have loved to really start from there, or having someone tell me that. And so the that's another thing about the deductive and inductive thing. Right now, the coolest thing is probably to do machine learning with those vectors where we reason, we make some reasoning with those vectors, and we all, since there is some reasoning, we often say, hey, that's semantic. So that's why I think there is two approaches in behind the term semantic. The 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 most recent one is probably the vector based one. So those are large language models. For instance, you give a computer a lot of data, it's going to start from the data, extract some pattern, and from those pattern, derive reason about the pattern he has learned over the data. That's the inductive learning. You start from, it's a bottom-up approach. You start from the data, you crunch the data, and you extract some generic patterns and you use those patterns to reason. The way we typically use vectors to represent those abstract patterns, because that's another tool that the computer is very good at using. Doing vector computation on computer is very easy. But on the opposite, you can do the top-down approach, let's say, where you gonna describe your knowledge. I've got some knowledge about a specific domain. I'm gonna use symbols to describe it, and then I'm gonna teach a machine how to use those symbols to derive new facts.
And by symbols, you mean words, right? Because characters
Mm,
and
yeah.
words are symbols.
Yep, exactly. Symbols is, you gotta make a decision at some point, like maybe you're gonna use the a letter, let's say the letter A, to say that's what I mean behind. But some people have worked on, okay, let's define a very minimal set of rules and start from there.
Like
And
pictograms, like pictures of like symbols, like
mhm, you can
like
imagine pictogram. if you want.
Okay. Like a
Anything.
sun and a cloud and a water droplet. Is that what you mean?
Hmm. But what you say is that if I've got those two pictograms, then it means that I also have that one.
Hmm.
That's one rule. Okay. And they define a very minimal set of those rules, and they write down the standard and have people agree on this minimal set of rules. And those rules are very abstract, so they enable you to start from there, derive new stuff, so express knowledge in a symbolic manner. And but because you start from there, you can always apply those rules, those very generic rules.
Wh-
So
What is it? What is the point of that?
the point of that is just to have being able to have a machine use the knowledge that you have in your head.
In finding a way
Okay.
of unifying the communication between man and machine, right? Or woman and machine,
Hmm.
or people and
Yeah,
machine.
exactly. Yeah, I'm using the word, yeah, I don't want to go down that path, but I'm using the man in the sense of humankind.
Right.
Yeah, no man, woman, whatever. Man in the
Yeah.
sense of humankind.
Close.
That's another very hard topic. So
Yeah.
knowledge graph is hard enough. I think there's other, anyway.
So we talked about search engines. Google is a gigantic search engine.
Hmm.
Uh, Amazon is a gigantic search engine and fulfillment center.
Hmm.
We have eBay, another search engine based around niche goods and communities that they sell products that would otherwise be inaccessible.
Hmm.
Um, what are other examples? Pinterest is a search engine, right?
Every company has a search engine
Spotify is
now.
a search engine. Yeah,
Spotify.
but these are all like curating products or ideas or books or music or video. Netflix is a search engine.
Hmm.
Uh, that is the basis of your work: information extraction and information retrieval. Right, building systems
Hmm.
that enable people to share access to that information. Right.
Yep. And we have to make a distinction between the search engine and a recommendation system. You spoke about Google. It's sometimes hard to distinguish, is Google really a search engine or a recommendation system?
Well, let's look at Amazon. Amazon is a search engine. You search for the thing, but when you go into the
Uh,
product page, underneath it'll have recommendations for
mhm.
like products,
Yeah,
right?
yeah, yeah. And that was actually, it's sometimes very confusing. And if you take the example of my company, they ask me for a search engine because that's the word they know. But I think they might actually want a recommendation system. They don't, but I'm doing search engine because that's the PhD work. They say should do a search engine. At some point you gotta narrow down your topic otherwise.
Well, let's talk about trace parts. Trace parts is you said it was I mistook it to be a manufacturer, but
Mm-hmm.
you
Don't.
clarified it's a marketplace for manufacturers, right?
Their main work is to do digital marketing.
Hmm.
They do those mailing lists for companies like you take Schneider Electric, you take SKF, you take, I don't even know, there is so many, and they can do some digital marketing, so send emails to a bunch of clients, all the stuff. They can do all the stuff, and they also let you upload your catalog of products on their website. But they don't, on the website, there is not only the catalog itself, it contains the 3D models.
Hmm.
But that's the interface, that's
Well,
not the product.
they do several things. Under the context of your project, you're merely looking at the
The search
ideas.
engine part.
Yeah, the search engine that ties in the ideas and the metadata, right? Because you're
Hmm.
talking about first is the capability of how do you look up these entities, and then afterwards is how do you make recommendations based on the description of this entity, right? If you like
Hmm.
apples, maybe you like pears. I don't know. Maybe you like persimmons. Um,
So I don't do the recommendation part, but
mm,
what I do is currently the system is based on text. Okay. I'm a
mm.
user, I'm writing down some text, and if I make it very simple, the system is gonna take your text and look for the documents that contains this piece of text. And it causes a lot of problems because, well, human, they say the same thing with many different words. So the text that's gonna end up into your search engine as a request, it's um, it can be very different from one user to another, though the user wants the same thing. And it can be very different from what the person that created a product used to describe it. Okay. And I'm not even mentioning the languages. If I search in English, we have like 25, I think it's about 25 different languages on the website.
Hmm.
Okay. It doesn't mean that every product has 25 languages. It means that you can find products with descriptions in 25 different languages. But it also means that if I'm looking in English, or if I'm looking, let's say, in Chinese, my search query is in Chinese. I never gonna match stuff that are in English.
So now you're bringing another layer of complexity to just like information retrieval. Now it's
Hmm.
user experience and the context of the person that is behind the computer screen interacting with the system. Um,
Hmm.
you mentioned vocabulary. You mentioned, you didn't say it directly, but I anticipate you mean synonyms, right?
Hmm.
Like I say this word, I might say screw, but I might mean something else, right? Um, and you said that this is sort of like a house for several different kind of manufacturers. So like you said, each manufacturer can upload one or more catalogs. What is the scale or what is like the size of this database of products? How like if you were to try to quantify it and just reason
It's
with that.
infinite. That's one of the issues is that the number is theoretically infinite, just because some okay, we're gonna call them data providers. So the clients are the data providers. They describe the component using a formula. Okay, they tell you something like, I'm setting screws. They can be from 1 centimeters to 10 centimeters with a diameter going from 1 millimeter to 10 millimeter. So it
These are
means that you can technically generate an infinite number. And the description goes with, so change with the thing that you generate.
So they're not selling hard values, they're selling capabilities. They're selling, oh, like if you want a million screws, you tell us the specifications and we'll make it for you.
So that's what the trespass client does. But the people using the trespass platform, they are like the engineers that are building a machine, and before actually building the machine, you get a model your machine. You do a 3D models. And
Okay.
maybe for screws, pumps, whatever, you don't want to redo the model yourself. It's a waste of time. You can
Yeah.
go on the website, search for it, just download it, add it to your machine, and that's it.
Okay. So say I wanted to make a toaster and I'm designing a toaster from scratch. I don't want to
Hmm.
design a screw. I'm gonna go in trace parts, download the screws that are based on standards, metric or
Hmm.
otherwise, and plug that into my 3D model of a toaster. And then when I want to manufacture, I know that I can go to trace parts and I can contact the manufacturers of that part, right?
So you talked about metadata.
Yes.
When you download the 3D model, and
Uh-huh.
that's the important part, you don't download only the 3D model. You also download the metadata that are tied to it. And
Okay.
in those metadata, there is where does these 3D models come from?
Okay.
And when it comes to at some point in the modeling process, you reach the point where you get to actually build a machine. and there is the sourcing phase
Hmm.
somewhere there. And when it comes to sourcing, someone is going to look at each of the component of your machine under your 3D models,
Hmm.
and the metadata is going to be there. And if the engineer took, I don't know, the screw or the pump from this company, then it makes sense for you to go look for this company because you know that they're selling what you need. That's how the system works.
Okay. Back to the work you're doing for them.
Hmm.
You're gonna tie in this theoretical, infinite, mathematical problem from hell, on how to make the user intent explicit and help guide them to a solution so that trace parts can sell more products, right? So that they can provide a higher
Hmm.
value to customers and sell more products.
What I'm trying to do is to have the user iterate less before they find the what they need on the website.
That
So
is the
one of the
that is a technical challenge, but the business challenge is how do you make more money, right? That's why it matters to them.
the yeah, what is matter? So if you, I'm not on the business side, but the business is very easy to understand. What the people that actually pay are the data, the supplier and the manufacturer that have a catalog and they decide to pay so they can put the catalog on the website.
Hmm.
The user, they don't pay. The people that goes on the website and download 3D models, they don't pay. But it's the same when you're going on Facebook or you're going on Instagram or whatever social network. You're
Hmm.
going there, and for those company, the more people goes on the website, the more they can sell
Hmm.
advertisement. So the math they do behind is that if you have a better search engine, then your user are happier, so they come more. So you have more people coming to the website, so you can have more clients, maybe pay more or be more satisfied as well. Does it make sense?
Yeah, no, for sure. I just wanted to hear from your mouth, you know, because this is a thing that all scientists and engineers and academics do. They talk about the technical problem, but they fail to mention the context of the business impact, right? And you very very elegantly painted that picture of what is the benefit to to all actors involved: the business, the customers, and the manufacturers paying the business.
But
Um,
my take on that is I get I think I get how they thought about it. In the company, I think they identified the need. They thought about what are the ways we can enhance our have our client more happy, and they ended up with the thing that they need a better search engine. What I really think is that they have a wealth of data. Like many company, they have many data, but it's not that structured, and it's very in the it looks like raw data, and at some point you cannot make sense of it. And I think bringing this knowledge component, so the knowledge graph component, can help make sense of all the data you have. And when you bring this knowledge, it can be used internally, externally. It can be used in many different places of the company.
I think you
Designed well.
I think you said it beautifully in the one sentence that you said. You want users to iterate less before they find what they're looking for.
Mhm.
That's what's deriving value. You're shaving the
Yeah,
waste.
but my point is, so okay, you do the entire process. The company, they identify the need. Okay.
Hmm.
I'm going to skip the details of the why and hows, but they decided to make a PhD about to solve this issue. They decided to go with a PhD, and that's me. In the PhD, it said I should design a knowledge graph. Okay, I should use a knowledge graph. They are thinking like the knowledge graph is going to enhance the search engine. But to me, the knowledge graph is a tool that you can use in many different places. In there, the search engine is one use case, but if the knowledge graph is well designed, it's like it's a piece of knowledge, and knowledge can be used in many different places in the company and
Right.
in many different manners. You can reuse that in different manners.
You're not building just a knowledge graph. You're building a semantic layer that allows you to create semantic applications because it's
Hmm.
sort of like an API, a semantic layer, a meaning layer lets other intelligent applications be created. That's the foundation, that's the bedrock,
You
right?
know,
The
and
pyramid of
I
right?
exactly, yep. And that's this, the keyword semantic layer. It's used in a lot of company. Um, I think it makes a lot of sense, and it's more and more important because with those large language model thing that just came out, I think we are shifting the way we are looking for stuff. The interface we are using to look for things on the internet or on any places, it's shifting towards um, you take Google at the beginning, you gotta write a query or something, and they're gonna get you back the 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 web pages that might contain your answer. And that was like the very beginning. And then they started to, let's say, make the user job very, very simple, more and more simple. At first, they just say you, oh, the answer might be somewhere in this page or this page or this page. Now they're telling you, oh, the answer, your question is that, we have the answer there, and it just, directly show you the snippet of text that answer your question. It's even worse now. They want a chatbot. They want to interact like I'm talking to you, and you're the expert, and you're gonna get me the answer.
I
You see
think one
how the looking for information change.
I think one of the problems with advances in technology is that they amplify stupidity. And sometimes people think that they can
Yeah.
solve problems with brute, like technical innovations, but it doesn't solve the core issue of lack of thought, or clarity of
Hmm.
thought. A business should know what they want to do and how they want to do it. And if they don't know, then they should spend some time to research, develop, and experiment to learn so that when they have adequate amount of resources to make a sizable investment, they can then go do that in a reduced risk, right? Um, but I think even just investing in a semantic layer is a good start to not risk, but it just adds value all around because you're just making you're helping an organization preserve its corporate knowledge
Hmm.
and also extend its technical capabilities to develop search engines or recommendation systems or anything else, right?
I think you say this idea of preserving a corporate knowledge and investing in the semantic layer. Make sure this corporate knowledge is going to be human understandable, and it makes sure that you're going to be able in the future, let's say this piece of knowledge that I think IKEA is the right example. You remember the presentation from IKEA? I don't know if you went when we were at the KGC conference. There was a
Um,
presentation from what her name? I forgot her name.
Katarina Kari.
Katarina Kari. That's it. Yeah. And one of the things she said is they have a lot of designers to know how to design. They know exactly if they have a room and someone with specific needs, they know how they should design the room and what kind of furniture they put in. And this knowledge, they before it wasn't represented. It was only in the head of designers. So when your designer leave the company, you don't have access to this knowledge anymore. A semantic layer makes sure this knowledge become persistent and stay available for anyone, and you can build on top of it.
I think Matthias, that you're saying you're painting an example, but it's a very rare example because IKEA in itself, in the DNA of the organization, they do value first. They do knowledge first, customer first type of thinking. Hence, the fulfillment and logistics and manufacturing of things. comes from that idea of how do we manage knowledge so we can know what
Yeah.
to build. You know, that's not.
Can you can you can you tell me one company that doesn't have a senior developer, whatever, one company that doesn't have a senior employee that acquired knowledge about the company along the years, and this person is about to leave or retire or whatever, and you know as a manager that when this person leaves, he or she is going to leave with the knowledge,
Yeah,
and you're
yeah.
going to have to replace that.
That's the absence of that's the absence of retaining that corporate knowledge that I
Hmm.
mentioned earlier. No, but I'm saying IKEA is a special example. You know, I do freelance business consulting with small
Hmm.
businesses, with friends, whatever. Um, if you go up to them and you ask any like a lot of small medium sized businesses, you go and ask them how do you do what you do, and you ask for instructions or documentation that doesn't even exist.
Hmm.
Everybody has the implicit understanding that, oh yeah, you're a business. A business documents their processes. A business writes down all the contacts, the relationships, the interactions. You would make that implicit assumption, but it doesn't exist. The world is messy in itself, you know. So, I mean,
So
this
you
is a
mean IKEA is already very far ahead
yeah,
compared to many? Yeah, that's
yeah.
true. But
Mhm.
you have to start from somewhere, and I think you could, you could tell the knowledgeable, like the senior person that's gonna leave, okay, before you leave, you gotta write down on paper everything you know about the company, everything you learn. But this is text, When you put text on paper, it's an expression of what you think. When you use a semantic layer, those knowledge graph structure, it's formal. Someone
Well,
new is not gonna interpret. The knowledge is in the knowledge graph itself. The interpretation is itself in the knowledge graph.
I think what you were saying is sort of a the knowledge transfer, an offboarding procedure, and that does preserve knowledge, as you said in text.
Hmm.
You may be able to train some people in that knowledge, but they will not have the experience or the reasoning capabilities of that senior employee. But a knowledge graph, if you have statistical information, if you have data points, and you have the reasoning, the knowledge capabilities of a senior employee, you have a very powerful knowledge based asset.
I think you're never gonna be able to replace the experience part. Someone that spent 10 years in a company, he or she has experience.
Well,
You're
humans,
never gonna be able to move that directly to the newcomer, the new employee.
no,
But
you
what you
no,
can do is the knowledge resulting from this experience, you can store it in a manner that is directly reusable by the new person coming.
you can't replicate the experience of a senior and a junior on with
Hmm.
outside of time. Time and proper HR training and upskilling and good procedure hygiene inside of the company. That's going to build a good employee. But you can empower an artificial system, a semantic layer with the the power, the wisdom of a person with sheer data points. If you do a
Hmm.
lot of transactions, a machine will be able to understand what's good and what's bad, and what are the inputs and outputs of those drivers. And if they're explainable, if you can see how they're fed through, then you can make corrections. So in some aspects, machines are better than humans in a corporate level.
Hmm.
But
And we agree that we cannot replace experience.
mm,
So you say in the sense that you agree with we
yeah, you
cannot
can you
replace
can
experience.
you cannot
Yeah,
you can replace experience. No, it's a
but
human
you
thing.
can but you can store and build on top the knowledge resulting from this experience. That's what we're saying.
Layering, yeah.
Something interesting is I think we can, however, make the learning experience faster nowadays
I agree. Yeah.
with those, and it's not only because we have access to the knowledge, it's also I'm thinking of what you one use case of those conversational chatbots, those very advanced. If they have access to the knowledge and they act as an interface with the human, okay, so they can chat with you. It can provide feedbacks on whatever you do, and this feedback is what makes you grow faster. To me, the how you learn faster is to get feedback all the time.
Yeah, that is the biological and
Hmm.
educational development of people. If
Hmm.
you make a mistake and I tell you 6 months later at your semi-annual check-in, you're gonna be like, "Yo, what the hell? You should have told me that 6 months ago." You know,
Oh yeah.
"Oh, I was waiting it for a review." You know, like, but if you get that immediate piece of feedback, ouch, fire hot, I'm burning my hand. Ow, you know, I'm not gonna
Yeah.
do instantaneously. Um,
Family Pierre After, you're back on the prehistoric stuff.
or just
Learning that fire burns.
I burned my hand, you know? I didn't know that the fire was hot.
Yeah.
Um, so, you know, I think we're nearing the end of the conversation, but I think we should take some time to retroactively summarize what we've talked about and see if we
Okay.
can bring some meaning to some of the terms that we used, right? You want to go?
That's an hard exercise. So essentially, what you want is if any term, I might not remember all the term, but I can try to think about, following back. We started from there. That's where we ended up.
So
Okay.
we started with your PhD journey. We talked
Mm-hmm.
about the hardships that you faced in learning about how fragmented the meaning of meaning is, or the study of intelligence, or the study of knowledge graphs is. Terms have different meaning according to who uses them, what kind of groups, and the context around them. Um,
And I
and you
think
go ahead, go ahead.
on this, you mentioned the community aspect. You gave I think it was a very good example. And you have to always make this exercise in your head. Like if you ended up alone and you had to come in a new community, how would you communicate what you've learned? How would you converse with this community? I think that was a very good example. Um, so yeah, we're starting from the PhD, or I basically presented myself.
Hmm.
We moved on to the notion of semantics, how it works,
Share
how the sharing meaning, yep.
in a
And
organization.
I think that was the end, the corporate part.
But somewhere in between, we talked about the semantic layer and how that shares meaning, but in a technical level.
Mhm.
Um,
So I think I also mentioned before that I went on describing what is a knowledge graph to me, when I spoke about there
domain
is,
data
yeah,
graphs.
domain data merging
Merge-
both. And when I say merging both, the thing that I haven't said is that there is a mapping between both.
Mm,
And that's the also the important part. You have your data, you have your knowledge, but you got to map both. So um, we talk about the inductive versus deductive
mhm.
reasoning. So basically, the bottom up, starting from the data to derive pattern and use those patterns to reason. That's the inductive process. Deductive is the opposite. You describe your pattern using symbols, and you use those symbols to reason
Figure it
about your
out.
data.
Mhm.
Um, and
The
then we
important
moved on to trespass, I think, the company.
the importance of search engines and
Oh yeah.
how
Oh
complex it can.
yeah.
It's
And
two-sided
make
coin. You have the data, you have the meaning of the data, you have the interface, you have the language, the intent
mhm.
of the person, and how to reason across like all that layer, right?
Yep. And I think one point was making sure you ask yourself, is it really a search engine, an information retrieval system, or is that a recommendation system? Because some nowadays, it's kind of a confusion.
Mm.
Um, And then we moved on to, I think this part wasn't that important, about how the company, what is the business of the company. But in this, what was interesting is this human interface to search engine, how it evolves. We started from expressing a query and having a search engine pointing us to the documents that might contain the information. And nowadays, we want to ask a query in natural language and directly get the information, not even having to look down into the document.
We want to be in the Iron Man movie where we have a personal
Oh yeah,
like,
Jarvis.
turn on the TV, make my coffee, you
Uh-huh.
know, bring me a
Yep.
bagel. Yeah.
Oh yeah. But I like reading about the story of computer science, and I'm thinking about the mouse part. The thing that you're using. At some point, there was, I don't remember the guy, the engineer that thought about that, but this piece, it's an engineer that thought, oh, that's going to be the user interface, the human machine interface we're going to use to interact with our day every day with our computer. And I thought that was, wow, why? It could have been anything. It's like keyboards. Keyboards, they thought about having ergonomic keyboards that have the most used letters and they are directly under your fingers. That's not actually how it is right now.
Yeah, well, they modeled the keyboard off of a typewriter, but it was never like ergonomically based. They sell keyboards that instead of having one rectangle, you have fragmented double-sided keyboards, and it's you can
Mhm.
actually put a hand on both sides and type and switch the and modify the different keys. Um,
I I think the story about keyboard, I might be wrong, but the thing that I remember is before it was typing machine. You know those arms that were typing on
mhm.
you were pressing a key and was typing. And they did actually the complete opposite. They wanted the most used letter to be as separate as possible because if you were going too fast, those two arms were kicking each other.
Oh,
So
I
you
like
wanted them to be very slow. So,
cool.
but by the time the people got used to how the keyboard was structured,
They already
so it
destroyed
ended up so it
it.
ended up in the computers. But nowadays, what you really would like to have is you have the most used letter very close to your fingers and close to themselves, so you don't have to move faster on the keyboard. I might be wrong on this story. It just makes sense to me that
It's a
it
cool
happens like
story.
this.
You
So,
could be making this up, but I believe it. um,
so
yeah, cool, man.
anyway, I think that was very interesting. I like that.
I like this
Thank you,
con-
Joaquin.
I like this conversation the second time around. It feels a lot more free.
It is. It makes very much more sense as well. Okay, I think we can stop there. Thanks, Joaquin, because I gotta go as well.